Hi students. So today we are continuing the topic projectile from an inclined plane. So in the previous session already we have seen projectile from an inclined plane. Suppose if this is an inclined plane, the angle of inclination, if it is alpha, and if we are projecting like this, if this angle is theta, then we had calculated time of flight. So 2u sine theta divided by g cos alpha. So why cos alpha? If g is acting in this direction, then if this is alpha, this is g cos alpha, and this is going to be g sine alpha. If this is u, this is going to be u cos theta, and this is u sine theta. Okay, hope all these informations you are clear. Okay, now 2u sine theta by g cos alpha. This g cos alpha is also vertical component of g, and u sine theta is also vertical component of u. So putting together you can write like a 2uy divided by gy, time of flight. So this we have seen in the last class. Then maximum height is u square sine square theta divided by 2. Instead of just g, we can have g cos alpha. Okay, so here this also uy square divided by 2 into gy, correct. Then time of flight, range, horizontal range, again that also we have derived, but in order to do problems we need not use that formula. We can do using applying the concepts. Okay, so range also we have derived. Okay, range also we have derived. All right, now just a few relations. The maximum range, we will be getting for what angle, all these things we shall see today. Okay, right. So here we are going to see, I am erasing this. Here we are going to see a relation between, okay, relation between alpha and theta. Okay, relation between alpha and theta if the projectile hits the inclined plane. Okay, hits the inclined plane perpendicularly. Okay, hits the inclined plane perpendicularly. Okay, that is so I'll draw here. Suppose if this is an inclined plane, if we have projected from here, so it comes and hit in here. This is pakka perpendicular, that is normal to the plane. It is hitting normal to the plane. Which plane? Inclined plane. So for that condition, what is the relation between alpha and theta? So that relation we will see, and we can make use of it if we get any questions like that. Okay, so here if it is hitting like this, okay, if it is hitting like this, we know that here this Vx is going to be 0 and this direction is going to be Vy. Correct or what? Now applying the fundamental equation, V is equal to U plus AT, Vx is equal to Ux plus Ax into T. Okay, now here Vx will be 0, Vx will be 0, and what is the horizontal component initial velocity? That is u cos theta, and what is available in x direction? Suppose if we consider this as x direction and this as y, we know this g sin alpha is negative because motion is in this direction. So if we consider the movement, displacement or velocity in this direction, this acceleration is opposing it. So we can write minus g sin alpha into time. So what is time here? Time taken to reach this point, that is nothing but time of flight. So into time of flight 2u sin theta divided by g cos alpha. Okay, hope this equation is clear for you. Done. Okay, shall I erase this figure? Okay, so now bringing that term to this side, we will be getting finally g tan alpha. Okay, so here g and g will be cancelled off, so tan alpha it will come to this side, tan alpha into 2u sin theta is equal to u cos theta. We will be getting like this. So here this u can be cancelled off. Finally we will be getting tan alpha. 2 tan alpha is equal to what? This will go to this side and this will become cot theta. So this is the relation between the angle of inclination and the angle of projection if the projectile hits the inclined plane in the perpendicular direction. Okay, so remember this relation, note it down. Okay, now we will try to find the maximum range for a particular angle. Okay, done. Maximum range for a particular maximum, we know the formula for range is r is equal to u square sine 2 theta divided by g, u square sine 2 theta by g for a normal projectile. So for a normal projectile we know sine 2 theta will be maximum, that is 1 when theta is equal to 45 degree, so that we will be getting the maximum range R max is equal to u square by g. This is in the case of a normal projectile, not inclined plane, a natural normal projectile. So here maximum range is at angle 45 degree. So in the same way, for what angle we will be getting maximum range in the case of projectile from an inclined plane. Now in order to find the angle to get the maximum range in an inclined plane, okay, so this is an inclined plane, this angle is alpha and this is projected with an angle theta. Now what is the angle in order to get the maximum range in an inclined plane? So what is the formula we have derived for range. So this, as I said, this formula is not required to solve problems. We can solve the problems by applying concepts, but in order to derive this theta, okay, theta for maximum range, I am using this equation. Okay, so this equation is what? 2u square sine theta cos theta plus alpha divided by g cos square alpha. This is the equation for range. Now maximum range, in order to find maximum range, at what angle, what we should do? We should differentiate it and equate that to 0. So if we plot in graph y-axis and x-axis, where the slope is 0, there it will have maximum value. So that technique we will be applying here. Okay, so dr divided by d theta will be equal to 0. The value of range will be 0 at what angle? Okay, so dr by d theta is equal to 0. Now if we differentiate this, we will be getting g cos square alpha 2u square sine theta into, this is sine theta plus alpha, okay, plus cos theta plus alpha into cos theta. This will be equal to 0. Clear? This term will go there, that will become 0. Now, so from here we will be getting, from this relation, this will also will become 0. So cos A cos B minus sin A sin B is equal to what? Cos A plus B. So that is the relation here. So I could write cos theta plus alpha plus theta. Okay, this is equal to 0. Okay, understood the relation? Now what I am getting is simply cos 2 theta plus alpha is equal to 0. So cos theta is equal to 0 when the angle is pi by 2. When the angle is pi by 2. So I am using that here. So 2 theta plus alpha. 2 theta plus alpha is nothing but pi by 2. So from this I can write that theta is equal to pi by 4 minus alpha by 2. So for an angle theta is equal to pi by 4 minus alpha by 2, I will be getting maximum range. I will be getting maximum range. Now what changes will happen to this formula in order to find maximum range, that also we will see. Now you note it down. Okay, clear? Shall I erase this? Okay, so suppose if we take an inclined plane like this. Okay, now what is the angle? Angle is equal to pi by 4 minus alpha by 2. This is what we have derived, pi by 4 minus alpha by 2. Now so if we project at such an angle, that is this theta, then we will be getting maximum range. So this is alpha and this is theta. This is theta. Okay, now please understand that this angle is how much? This angle is pi by 2 or 90 degree. This one and this one, that is pi by 2. So if this full is pi by 2 and if this is alpha, this full is pi by 2 and this is alpha, then this angle is nothing but pi by 2 minus alpha. Correct or what? That angle, the remaining angle, this one is, if this is alpha, this full is pi by 2, then this angle is how much? Pi by 2 minus alpha. Now you can see here, half of pi by 2 minus alpha divided by 2, sorry, pi by 2 minus alpha divided by 2 is what actually? Pi by 4 minus alpha by 2. That is if we project at half angle, okay, that is if we project the projectile at half of the angle between vertical line and inclined plane, we will be getting maximum range. Okay, so if we project a projectile, if we project a projectile at half angle, okay, half angle of angle between vertical line, see this is vertical line and this is inclined line, between vertical line and inclined plane, we get maximum range. Okay, so this angle is actually half of this angle. Okay, so that understanding must be there. Note it down. Right. Now, just like the maximum range for a normal projectile is what? U square by G. So same way, in this case, if we substitute this angle, what maximum range we are going to get, that we will see. So the formula for range is what? 2 U square cos sin theta, 2 U square sin theta into cos theta plus alpha divided by G into cos square alpha. So this is the formula for maximum, this is the formula for range. Now we will substitute this theta here. So R max is equal to 2 U square sin pi by 4 minus alpha by 2. Here cos pi by 4 minus alpha by 2 plus alpha divided by G cos square alpha. Now we'll expand this. So R max is equal to 2 U square sin A minus B. So sin pi by 4 cos alpha by 2 minus cos pi by 4 sin alpha by 2, one term. What about this one? So this will become what? Cos pi by 4, this is full, this is half, this will become pi alpha by 2. So cos A plus B. So this is going to become cos pi by 4 cos alpha by 2 minus, here it is plus, so here it is minus, sin pi by 4 sin alpha by 2 divide by G cos square alpha, divided by G cos square alpha. Please note it down. I need to further write this. Okay. So sin pi by 4, this term will become 1 by root 2. This term 1 by root 2. This also will become 1 by root 2. this will become 1 by root 2. Okay. So what I am going to write is R max is equal to 2u square. So here 1 by root 2, here 1 by root 2, I am taking it out. 1 by, okay, shall I write here? Okay students, hope you have copied this. Okay, I am erasing this. Okay, so R max is equal to this is going to be 2u square by g cos square alpha. Here 1 by root 2 we are taking out, so this will become cos alpha by 2 minus sin alpha by 2. This is one term. So from here also I will be taking 1 by root 2 common, so this will become cos alpha by 2 minus sin alpha by 2, second term. So this root 2 and root 2 will become 2. This we can cancel this. So this is same term. So R max is equal to what? U square by cos square alpha into cos alpha by 2 minus sin alpha by 2 the whole square. Correct or what? So I will be expanding this. When I expand this, R max is equal to u square by cos square alpha. This is nothing but cos square alpha by 2 plus sin square alpha by 2 minus 2 cos alpha by 2 sin alpha by 2 cos alpha by 2. It will come like this. Okay, so sin square alpha by 2 plus cos square alpha by 2, this is nothing but 1. So R max is equal to u square by cos square alpha into, this is 1 minus, this is what? 2 sin theta cos theta is nothing but sin 2 theta. Sin 2 theta is nothing but 2 sin theta cos theta. So I could write this like sin 2 theta. So here this will become 1 minus sin alpha. This will become 1 minus sin alpha. So what about cos square alpha? Cos square alpha, shall I erase this? Note it down. Please note this down. Okay, so I am erasing this. Okay, done. So cos square alpha, this becomes R max is equal to u square by cos square alpha. I can write like 1 minus sin square alpha, and this will become 1 minus sin alpha. So this thing I can write like R max is equal to u square by a square minus b square for 1 plus sin alpha into 1 minus sin alpha. So here 1 minus sin alpha is already there. So this will cancel each other. So I will be getting R max is equal to u square by 1 plus sin alpha. Okay, so R max is equal to u square by 1 plus sin alpha. So this is the maximum range for what angle? For this angle. This is the angle where we are going to get the maximum range. Okay, so note it down. Clear? Shall I erase this? Okay, so done. So dear children, so R max is equal to u square plus 1 sin alpha. This is for bottom to top. Bottom to top. So from top to bottom in the inclined plane, we can do this. R max is equal to u square divided by 1 minus sine alpha. R max is equal to u square divided by 1 minus sine alpha. So from bottom to top over the inclined plane, okay, R max is nothing but u square by 1 plus sine alpha. Angle is theta is equal to pi by 4 minus alpha by 2. And from top to bottom in the inclined plane, if the R max, if we need to get same angle, but R max will be u square by 1 minus sine alpha. Okay, note it down. Now let us do some problems based on the maximum range in an inclined plane. Okay, so one question is, for a given velocity of projection from a point on inclined plane, the maximum range down the plane is 3 times the maximum range up the incline. So the angle of inclination of inclined plane. So here the maximum range R max up the inclined plane, this is equal to, okay, the maximum range down the inclined plane, okay, down the inclined plane is 3 times the maximum range up the inclined plane. Okay, now we need to find the angle of inclination. So down the inclined plane, we know this is equal to u square by g into 1 minus sine alpha, and this is equal to 3 into u square divided by g into 1 plus sine alpha, and this alpha is the angle of inclined plane, angle of inclination, angle of the inclined plane. Okay, now just solve this, we will be getting the correct answer. Okay, u square g can be cancelled off, so this is 3 minus 3 sine alpha is equal to 1 plus sine alpha. So if it goes to that side, this will become 4 sine alpha, it will come to this side, this is going to be 2. So sine alpha is equal to 1 by 2, so alpha is equal to what? 30 degree. Alpha is equal to 30 degree, right? That is the answer for this question, option A. Clear? Done. Another question, the maximum range of rifle bullet. Okay, the maximum range of rifle bullet question number 2, the maximum range of rifle bullet on horizontal ground is 6 kilometer. Okay, the maximum range, this is how the rifle bullet, this is actually 6 kilometer maximum range. So u square by g is equal to 6 kilometer. Now what they are asking is its maximum range on an inclined plane of 30 degree. So R max, okay, up the incline, we will take up the incline, it should be mentioned in the question. Okay, so here it is not mentioned, so let us take it is up the incline. Okay, just we will take like this. Okay, up the, so up the inclined plane is what? U square divided by g into 1 plus sine alpha. Okay, now u square by g, we know this is 6 kilometers, so 6 into 10 raised to 3 divided by 1 plus sine 30. Okay, sine 30, that is what. So if we solve this, we will be getting what? 4 kilometers will be getting. Okay, so option C. Okay, so here I am winding up the topic, the projectile on an inclined plane. Projectile on an inclined plane, we have covered the basic concepts, time, range, maximum height, maximum range, up the incline, down the incline, all these things we have seen. Hope you have understood the topic well. So practice more number of questions. Okay students, thank you, goodbye.